So dear students, now in this lecture we will talk about Fajan's method. That is the third type of precipitation titration. So it is an indirect method, just like Volhard's method, where you will find the concentration of halides indirectly, which is performed at neutral pH. The titrant in this Fajan's method will be silver nitrate. So burette will consist of the solution of X molar silver nitrate solution, and the indicator is fluorescein. So here the indicator is very interesting and unique. The fluorescein, that is an organic dye, which are weak organic acids and which has capacity to get adsorbed onto the positively charged counter ion layer of a solid particle, so which will form during titration. So this indicator has capacity to get adsorbed, okay, and that is why it is known as adsorption indicators, right? So in olden time, Casimir's Fajans have introduced this indicator which has capacity to get adsorbed on the surface of precipitate. Okay, and because of this adsorption, you'll find color change. Okay, so here you'll find some different sort of mechanism. Okay, indicators which are used in Fajan's method are acidic dyes or basic dyes. Their examples are given to you in today's indicator. Today's titration, we'll talk about fluorescein as an indicator. Endpoint will be the pink color. Okay, so which is detected with the help of adsorption indicator that imparts a distinctive color on the surface of silver chloride precipitate. So we shall see in detail about this Fajan's method. So initially, if we talk about principle, you will find precipitating reagent. So that means our silver nitrate, our titrant, will react with our ions of analyte. Okay, so that means suppose you want to identify or estimate chloride ion, then you will take the chloride ion solution in a conical flask and you will react it with our precipitating reagent, that means AgNO3. So it will form AgCl precipitate, and it has got a capacity to or it is also known as a colloidal precipitate. That means they create some sort of surface. Okay, and to that surface which has got property to adsorb its own ions. That means if it is composed of AgCl particle, then it can adsorb silver ion as well as chloride ion depending on its concentration. Okay, so that is the capacity, or that is the unique feature of these AgCl precipitate, right? So because of this, the process of adsorption of oppositely charged ions, you will find formation of secondary layer. So you can see in diagram, in first, before the end point, you will find a precipitate of AgCl and it is surrounded by chloride ion. After that, it will be replaced by silver ion. Okay, and to that silver ion, our indicator gets it will form some complex, and because of that you will find there is a color change. So we'll see how exactly it takes place. So initially in a conical flask we'll take our chloride solution. So when in your chloride solution it is added with our indicator as well, so indicator is fluorescein. So in your conical flask you have sample of chloride ion. Along with it, there will be an indicator, that means fluorescein. And when you add drop by drop our silver nitrate solution in that conical flask, what will happen is this silver nitrate will react with chloride ion and it will form precipitate of AgCl. So you can see in the center with the blue color the formation of AgCl precipitate. Now what happened is these precipitate are having, they are known as colloidal precipitate. That means they have the capacity to absorb similar ions. So they are composed of, these precipitate are composed of silver ion as well as chloride ion. So it has got capacity to absorb Cl minus ions or Ag plus ion depending on its concentration in the conical flask. So initially what happened in your conical flask, you will find when you start adding AgNO3 from the burette in your conical flask, just imagine the scenario of conical flask. It is having some part of AgCl which is recently formed, more concentration of chloride ion, and remaining or the some part of what you call our indicator. Okay, so because of that, when this AgCl precipitate forms, it will attract the it can attract either silver plus ion or chloride minus ion, but at this point of time you will find more concentration of chloride ion. So around this AgCl precipitate you will find there is a formation of primary adsorption layer. So this AgCl will surrounded by chloride ion, right? So if I can show you with the help of some pen and all. Yes. So this will be our precipitate, and because of more concentration of chloride ion in the uh, conical flask, this precipitate this precipitate absorb chloride ion. So you will find this whole layer, this AgCl is precipitate જે છે એની આજુબાજુ chloride ion નું layer form થઈ જશે. That will be our primary adsorbed layer. Excuse me. Now, because of this formation, you will find આ જે વ્હાઇટ કલરનું જે સર્કલ છે ત્યાં બધે જ તમને માઇનસ ક્લોરાઇડ માઇનસ બધે, એટલે માઇનસ ચાર્જ તમને દેખાશે બધી જગ્યાએ. ઓકે, સો બીકોઝ ઓફ ધેટ ઓવરઓલ ચાર્જ જે થશે around AgCl will be minus. So because of that negative charge, it will attract positively charged ions. Okay, એ ક્યાંથી મળશે આપણને? Because we have taken a solution of chloride ion, that is nothing but NaCl. Okay, so chloride ion નું લેયર થયું, એના લીધે શું થશે? કોનિકલ ફ્લાસ્કની અંદર બીજા સોડિયમ આયન્સ બી ફ્રીલી અવેલેબલ છે, એટલે એનું લેયર અહીંયા આ જે ગ્રીન બાઉન્ડ્રી બતાવે છે એ શાનું લેયર હશે? ઓલ ધોઝ આર Na+. All those are Na+. So because of the attraction between positive and negative charge, you will find this kind of figure. Okay, so initially this type of reaction will be there, and the color of the solution will be yellow green. Why? Because that is the color shown by the non-adsorbed fluorescein dye. Okay, so this is the first case, or this is the case before the endpoint achieved. Now what will happen when almost all chloride ion gets formed precipitate with silver ion? So when, just imagine at the end point means no more chloride ion is present in the conical flask. So that means જેટલા બી chloride ion present હતા બધા જ આમાં utilize થઈ ગયા for the formation of AgCl precipitate. Now what this precipitate will do, again it has capacity to absorb its own ions, so it will absorb now silver ion. ક્યાંથી આવે? Because we are, આપણે તો titration કરી જ રહ્યા છે. જેમ જેમ titration કરશું, you will find more and more concentration of AgNO3 inside the conical flask જે titration burette માંથી આપણે એડ કરીએ છીએ. So now no more chloride ion is present. So in conical flask only silver ion and nitrate ion. Okay, so now it attracts silver ion. So now you will find this AgCl is surrounded by positive ions. That is because of silver ion. Okay, so that is our, now this will be our primary adsorb layer. Initially, it was of chloride ion because more chloride ions were present in our conical flask. Now it is the case where no chloride ions are present in conical flask because જેટલા બી હતા બધા જ AgCl ફોર્મ થવામાં કન્ઝ્યુમ થઈ ગયા. ઓકે, તો શું બચ્યું બીજું? ક્લોરાઇડ આયન તો પતી ગયા, તો આપણી પાસે શું છે? સિલ્વર આયન્સ. એ ક્યાંથી આવે છે? બ્યુરેટમાંથી. So now this AgCl will form, or it is now surrounded by Ag plus ions. એટલે આખું જ જે ઓવરઓલ ચાર્જ થશે એ પોઝિટિવ થશે. Now it will attract negative ions. Okay, that means શું બચ્યું? negative ions, NO3 minus, right? So now this is the case. NO3 minus ions present હશે બધે જ અહીંયા. આખી જે લાઈન છે ત્યાં બધે તમને you will find NO3 minus ion. But what happened? So that will be our secondary adsorption layer. But after addition of this silver nitrate, it will react with, or it will have some reaction with the what you call fluorocene as well. એટલે આની સાથે fluorocene ના ions બી હશે conical flask ની અંદર. Okay, so now what will happen is fluorocene ion, they are also minus ions. So now NO3 minus ions જે છે they will be replaced by fluorocene ions. Why? Because this fluorocene has capacity to form complex with silver ion. AgCl જે છે એની આજુબાજુ સિલ્વર આયન્સ છે, બધે જ અહીંયા સિલ્વર આયન્સ છે, આ જે વ્હાઇટ પોર્શન છે ત્યાં. અને જે સિલ્વર આયન્સ છે એનું લેયર ફોર્મ થયું છે એટલે શું થશે? ઇટ વિલ એટ્રેક્ટ નાવ NO3 માઇનસ ને આયનને એટ્રેક્ટ નહીં કરે, પણ ઇન્ડિકેટર આયન બી છે એટલે ઇન્ડિકેટર આયનને એટ્રેક્ટ કરશે બીકોઝ એની સાથે એ કોમ્પ્લેક્સ ફોર્મ કરી શકે છે, રાઈટ? એટલે નાવ યુ વિલ ફાઇન્ડ આ જે ગ્રીન લેયર છે દેટ વિલ બી સરાઉન્ડેડ બાય એ શાનું બનેલું હશે? ફ્લોરોસિન આયન્સનું. અને જ્યારે આવું કન્વર્ઝન થાય ત્યારે એનો કલર ચેન્જ થશે. ઇનિશિયલી ઇટ વોઝ શોઈંગ યલો કલર કે જ્યાં આયોનાઇઝેશન નહોતું થયું ફ્લોરોસિનનું, અથવા આયોનાઇઝેશન તો થયું હતું પણ એનું અને ફ્લોરોસિન અને સિલ્વર આયનનું કોમ્પ્લેક્સ ફોર્મ નથી થયું. જેવો એ કોમ્પ્લેક્સ ફોર્મ થવાનો સ્ટાર્ટ થશે that shows pink color. So that complex will show us pink color in the conical flask. So that shows કે બધી જ રિએક્શન કમ્પ્લીટ થઈ ગઈ છે. ઓકે, એન્ડ પોઈન્ટ આવી ગયો છે, રાઈટ? સો નાવ ઇટ વોઝ અર્લિયર સેકન્ડરી લેયર કોનું બનેલું હતું? નાઇટ્રેટ આયનનું હતું. હવે એ ફ્લોરોસિન આયનનું બનેલું છે. So this shows, so ultimately અહીંયા યુનિક ફીચર શું છે કે જે AgCl ફોર્મ થયું છે it has got capacity to adsorb similar ions which are composed of that particular precipitate. AgCl નું બનેલું એવા સિમિલર આયન્સને એટ્રેક્ટ કરી શકે. And based on that you will find formation of primary adsorption layer and secondary adsorption layer. So at the end point you will find pink color, and a pink color form થાય એટલે ખબર પડી જાય કે end point achieve. No more chloride ion is present in the conical flask. Okay, so that is about Fajan's method. If you want to see the details of this Fajan's method, then you can આ જે અહીંયા લિંક આપેલી છે યુટ્યુબની એ તમે જોઈ શકો છો, where you will find titration or practical related to Fajan's method. So એટલે તમને વધારે આઈડિયા આવશે કે એક્ઝેક્ટલી તમને દેખાશે કેવી રીતના. ઓકે, સો that was about Fajan's method. ફર્ધર આપણે ફજાન્સ મેથડની વાત કરીએ તો યુ વિલ ફાઇન્ડ ફ્લોરોસિનની સાથે યુ કેન યુઝ ફ્લોરોસિનની સાથે ઇઓસિન, ટાર્ટ્રેઝિન બી યુઝ થઈ શકે છે એઝ એ ઇન્ડિકેટર, એન્ડ દે આર યુઝડ ફોર ધ સ્પેસિફિક એસ્ટિમેશન. જેમ કે આપણે ફ્લોરોસિનની વાત કર્યું તો ઇટ ઇઝ યુઝ ફોર એસ્ટિમેશન ઓફ ક્લોરાઇડ, બ્રોમાઇડ એન્ડ આયોડાઇડ આયન્સ with the help of silver ions. Eosin it is used for bromide and iodide ion, and tartrazine is used for thiocyanate and iodide ion estimation. And the color change bhi tamne અહીંયા આપેલો છે. What will be the final color change? Only limitation with Fajan's method is it is not applicable at low concentration. So it cannot work with very low concentration of the analyte. Why? Because if the concentration is very low, then AgCl formation જે થવાનું છે એ ફોર્મેશન થશે, બટ એક કોલોઇડલ પ્રેસિપિટેટ નહીં બનાવી શકે. કોલોઇડલ એટલે શું થયું કે એક પ્રેસિપિટેટ ફોર્મ થયું, એની પર બીજું થયું, ત્રીજું થયું, અને એમનું એક આખું લેયર થઈ ગયું, અને પછી એની પાસે કેપેસિટી હોય ટુ એબ્ઝોર્બ ધી similar ions જે possible નથી if the concentration of analyte is at lower strength. Okay, so it won't show us the color change. એક આપણને color change દેખાશે જ નહીં. And it is a pH dependent method. જેમ pH change થશે એમ any જે effectiveness છે એ વધારે ઓછી થઈ શકે. That's why that is the limitation of Fajan's method. Okay, now further part of this titration or precipitation titration is yes, argentometry. All these titrations are known as argentometric because here we are using silver nitrate as our titrant, and they are used for estimation of anions, specifically chloride ions, then iodide ions. All those anions can be determined by precipitation titration because they form slightly soluble compounds with the silver ions. Okay, their methods or two ways of performing argenometric વિધાઉટ ઇન્ડિકેટર જે તમારા સિલેબસમાં છે જ નહીં, બટ તમને તમારા ઇન્ફોર્મેશન માટે તમે જાણ રાખો અહીંયા કે વિધાઉટ ઇન્ડિકેટર બી પરફોર્મ થઈ શકે વિથ ધી હેલ્પ ઓફ ગેલ-લુઝેક મેથડ એન્ડ ફોર્મેશન ઓફ ટર્બિડિટી એટ ધી એન્ડ પોઈન્ટ. એવું બી તમે ચેક કરી શકો છો. આપણે જે ડિસ્કસ કર્યું છે with the help of indicators, they are the Morse method, Fajan's and Volhart's method. Okay. Now, if you talk about general applications of this precipitation titration, they are used for assay of many drugs. જેમ આપણે NaCl ની વાત કરી હતી, એટલે exact percentage weight by weight of કોઈ બી ડ્રગનું તમારે શોધવું હોય તો તમે શોધી શકો with the help of precipitation titration. Okay. So these are the peculiar points or peculiar applications of precipitation titration. Morse method થી NaCl dextrose injection, KCl નું estimation કરી શકો. Volhart's method થી aminophylline, silver nitrate, phenyl mercuric acetate, NaCl, all these drugs can be estimated. Okay, એમનું concentration તમારે શોધવું હોય તો તમે આ particular precipitation titration લઈ શકો છો. Okay, so that's it about precipitation titration. So if you have any doubts related to this particular recorded video, you may have your feedback in the Teams itself. Okay, so now we are signing off and we'll look forward for the remaining part of this chapter. Okay.